The internal wiring of an outdoor portable sign that is readily accessible must be supplied from and protected by a circuit breaker less than 50 amps. This requirement ensures electrical safety and prevents overcurrent situations that could lead to fire or electrical hazards. A circuit breaker is an overcurrent protection device designed to automatically interrupt the flow of electricity in a circuit when an overcurrent or short circuit is detected. The selection of a circuit breaker with a rating less than 50 amps provides a critical safety measure for outdoor portable signs. It's important to delve into the specifics of why this requirement is in place and what it means for the design, installation, and maintenance of these signs. Firstly, consider the accessibility of the wiring. Outdoor portable signs are often placed in public areas, making their internal wiring readily accessible to individuals who may not be qualified electricians or technicians. This accessibility increases the risk of accidental damage, tampering, or exposure to environmental factors such as moisture and extreme temperatures. The use of a circuit breaker acts as a first line of defense against electrical hazards in these situations. Secondly, the current carrying capacity of the internal wiring is a crucial factor. The internal wiring of an outdoor portable sign is typically sized to handle the expected load of the sign's lighting, display, and any other electrical components. The circuit breaker's ampere rating must be selected to protect this wiring from overcurrents. Overcurrents can occur due to various reasons, including short circuits, ground faults, or excessive load demands. If the current exceeds the wire's ampacity, the wire can overheat, potentially causing insulation damage, melting, or even a fire. Thirdly, the role of the circuit breaker is to interrupt the flow of electricity when an overcurrent condition arises. Circuit breakers are designed to trip or open the circuit when the current exceeds their rated value. This interruption prevents the sustained flow of excessive current, thus protecting the wiring and connected equipment from damage. The 50 amp limit is in place to ensure that the circuit breaker trips quickly enough to prevent significant overheating or damage to the wiring. The National Electrical Code, or NEC, provides specific guidelines for overcurrent protection. While the exact NEC article may vary depending on the specific application and sign type, the general principle of protecting wiring with an appropriately sized circuit breaker remains consistent. The NEC addresses the installation and wiring of signs in Article 600. It's important to consult the latest edition of the NEC and any applicable local codes to ensure compliance with all relevant requirements. The selection of the correct circuit breaker involves several considerations. One consideration is the continuous load. The NEC defines a continuous load as a load where the maximum current is expected to continue for 3 hours or more. In these cases, the overcurrent device must be rated no less than 125% of the continuous load. For example, if the continuous load of the sign is 10 amps, the circuit breaker must be rated at least 12.5 amps. The next available standard size circuit breaker above 12.5 amps would typically be selected. Another consideration is the interrupting rating. The interrupting rating of the circuit breaker is the maximum short circuit current that the breaker can safely interrupt without failing. This rating must be high enough to handle the available fault current at the sign's location. The available fault current can be determined through a short circuit study, which takes into account the utility transformer size, impedance of the conductors, and other factors. The circuit breaker's interrupting rating must be equal to or greater than the calculated available fault current. Furthermore, the type of circuit breaker is also a consideration. Common types of circuit breakers include thermal magnetic breakers, electronic trip breakers, and ground fault circuit interrupters, or GFCIs. Thermal magnetic breakers are the most common type and use a thermal element to trip on overload currents and a magnetic element to trip on short circuit currents. Electronic trip breakers use electronic circuitry to sense overcurrents and trip the breaker. GFCIs are designed to protect against ground faults, which occur when current leaks to ground. GFCIs are often required in outdoor locations to protect against electrical shock hazards. The proper installation of the circuit breaker is critical for its effective operation. The circuit breaker must be installed in a suitable enclosure that provides protection from the environment. The enclosure must be rated for the location, such as an NEMA 3R enclosure for outdoor use. The wiring connections to the circuit breaker must be properly tightened to ensure a secure and reliable connection. Loose connections can cause overheating and arcing, which can lead to equipment failure or fire. The circuit breaker must be properly labeled to identify the circuit it protects. This labeling helps facilitate troubleshooting and maintenance. The label should indicate the circuit's function, such as sign lighting or display power. Periodic inspection and maintenance of the circuit breaker are essential for ensuring its continued reliability. Circuit breakers should be visually inspected for any signs of damage, such as cracks, discoloration, or corrosion. The connections should be checked for tightness, and the breaker should be tested periodically to verify its tripping function. Testing can be performed using a circuit breaker test kit, which simulates overcurrent conditions to ensure that the breaker trips as designed. Replacement of circuit breakers should be performed by qualified electricians. When replacing a circuit breaker, it is important to select a breaker with the same ampere rating, interrupting rating, and type as the original breaker. Using a breaker with an incorrect rating can compromise the safety of the electrical system. Modifications to the internal wiring of an outdoor portable sign should only be performed by qualified electricians. Any modifications must comply with the NEC and other applicable codes. It is important to ensure that the wiring is properly sized for the load and that all connections are made correctly. Improper modifications can create electrical hazards and void any warranties. Grounding is another critical aspect of electrical safety for outdoor portable signs. The sign's metal enclosure and any other conductive parts must be properly grounded to provide a path for fault current to flow back to the source. Grounding helps to prevent electrical shock hazards and reduce the risk of equipment damage. The grounding conductor must be sized according to the NEC and must be properly connected to the grounding electrode system. Surge protection is also an important consideration, particularly for signs that contain sensitive electronic components. Surge protective devices, or SPDs, can help to protect against voltage surges caused by lightning strikes, power line switching, and other transient events. SPD should be installed at the sign service entrance and at any other critical points in the electrical system. The selection of SPD should be based on the expected surge levels and the sensitivity of the equipment being protected. Weatherproof enclosures are essential for protecting the electrical components of outdoor portable signs from the elements. These enclosures are designed to prevent the ingress of water, dust, and other contaminants that can damage electrical equipment. Weatherproof enclosures are typically rated according to NEMA standards, with higher NEMA ratings providing greater protection. The selection of the appropriate NEMA rating depends on the specific environmental conditions at the sign's location. Conduits are used to protect and route electrical wiring. Conduits can be made of various materials, including metal, PVC, and flexible metal. The type of conduit selected depends on the application and the environmental conditions. Metal conduits provide excellent mechanical protection and are often used in exposed locations. PVC conduits are lightweight and resistant to corrosion, making them suitable for underground installations. Flexible metal conduits are used in applications where flexibility is required. In addition to the circuit breaker requirement, there are other safety considerations for outdoor portable signs. These include ensuring that the sign is properly secured to prevent it from tipping over in high winds, providing adequate clearance around the sign to prevent obstructions, and using appropriate signage to warn of electrical hazards. Regular inspections should be conducted to identify any potential safety hazards and to ensure that the sign is in good working condition. Compliance with Underwriters Laboratories, or UL, standards is also important. UL is a nationally recognized testing laboratory that tests and certifies electrical products for safety. UL listing indicates that a product has been tested and found to meet UL safety standards. Many jurisdictions require that electrical products be UL listed before they can be installed. When selecting electrical components for an outdoor portable sign, it is important to look for UL listing to ensure that they meet safety standards. The NEC also provides specific requirements for the wiring and installation of temporary electrical power systems. These requirements apply to portable signs that are connected to temporary power sources, such as generators or extension cords. The NEC requires that temporary power systems be grounded and protected by ground fault circuit interrupters to prevent electrical shock hazards. Extension cords must be properly sized for the load and must be in good condition. The use of undersized or damaged extension cords can create a fire hazard. Proper documentation is essential for the safe operation and maintenance of outdoor portable signs. The documentation should include a wiring diagram, a list of all electrical components, and a record of all inspections and maintenance performed. The documentation should be kept in a safe and accessible location. Training is also important for personnel who are responsible for the installation, maintenance, and operation of outdoor portable signs. Training should cover electrical safety, proper wiring techniques, and the use of personal protective equipment. Qualified electricians should be used for all electrical work. The Americans with Disabilities Act, or ADA, also has requirements that may impact the design and installation of outdoor portable signs. The ADA requires that signs be accessible to individuals with disabilities, including those with visual impairments. This may include requirements for the size, location, and contrast of the sign's lettering. It is important to consult the ADA guidelines to ensure that the sign complies with all accessibility requirements. In summary, protecting the internal wiring of an outdoor portable sign with a circuit breaker less than 50 amps is a critical safety measure. This requirement helps to prevent overcurrent situations that could lead to fire or electrical hazards. The selection, installation, and maintenance of the circuit breaker must be performed in accordance with the NEC and other applicable codes. Regular inspections and proper documentation are also essential for ensuring the continued safety and reliability of the sign's electrical system. By adhering to these guidelines, you can help to ensure that outdoor portable signs are safe and reliable.